Hello, my name is Siddhant Amul Shah and I am here to present a TOC presentation on topic Decidability in Theory of Computation. So, before moving forward, let us try to understand what really decidability is. Before understanding decidability, we need to understand two basic concepts such as recursive language and recursively enumerable language. So, coming here, what are recursive languages? So, a language L is said to be recursive in nature if there exists a Turing machine which will accept all strings L and reject all the strings which are not in L. So basically, what it tries to say that a Turing machine is a language is said to be a recursive language if there is a particular definite stopping point of the machine, either reject or accept. So a Turing machine will halt every time and give an answer either accepted or rejected every single time we give them a string input. So this is known as recursive language. Now coming to recursively enumerable language. What is a recursively enumerable language? A recursively enumerable language is a language which will halt when we have an accept state. But here is a twist. It will sometimes halt or sometimes not when there is a reject state, which is it may or may not halt for all the input which are not in health, which it depends on the Turing machine we construct. These type of languages are known as recursively enumerable language, which can sometimes halt or sometimes not halt on the inputs which are not present in L. That's the main difference between recursively enumerable language and recursive language. Now that we have a particular understanding of recursively language and recursively enumerable language, let's move on to our main topic, that is decidability. So what is decidability? So a language L is said to be decidable if it is a recursive language. And what is a recursive language? A recursive language is a language which has a particular halt point. It is an either accept or reject. All decidable languages are recursive languages, and the opposite holds true as well. That is, all recursive languages are decidable as well. So here is a decidability theorem. A language L over sigma is called decidable if there exists a Turing machine which accepts the language L where if W belongs to sigma Z or else M halts. So we have a particular stopping point. We have either accept or reject based on the input. To make this more clear, I would like to show you this diagram and try to explain with this diagram. So if we take an input string here and check if a particular name is in it or not. So we will check if the name is in it or not. If the name is in it, it will go to the accepted state and it will halt the Turing machine. If the name is not there in the string, it will go to a rejected state and we will have a halt to the Turing machine. In the either of these cases, we will have an accepted or rejected state. That makes this problem decidable. Hope you understand what is decidability now. And let's move on to solving, like we will solve a couple of questions to get more deeper understanding of what decidability is. So here's the first question. We need to find whether the given question is decidable or not. And the question is a number m prime? So what the question tries to tell is, we are given a number m and we need to find if the number m is prime number or not. So going to our basic mathematics, what is a prime number? A prime number is a number which is only divisible by itself and nothing else. So here is a solution to it. A prime number starts from 2, 3, 5, 7, 13 and so on. And what we do is, to solve this problem, we will divide the number m by 2 and root m starting from 2. So what we are doing here is that if a number is divided by a multiple of 2 or by root m and the remainder is 0, that means the number is divisible by something else, which means that the number is not prime because it is divisible by something else, and then the machine will go in the rejected state. Otherwise it will go to the accepted state. So we, in the either case, we have the answer that m is a prime number or m is not a prime number. That is either a yes or a no. Therefore this problem is a decidable problem. Let's move on to our next question. Are two regular languages L and M equivalent? And we need to find if the problem is decidable or not. So it is pretty straightforward here that how do we come to know if two languages are same or not? what we do is subtract them from each other and see if the answer is null or not. So here is the solution. We can easily check this by using set difference operation. L minus equal m equals to null and m minus l equals to null. Therefore, if we take union of it and it is null, that means that both the strings offer us same length and both are equivalent to each other. Now, if we do not get the answer as null, that means L or M are not same and they have like many differences in them. So this makes them, this gives us a particular solution that is an equivalent solution or a not equivalent solution. Therefore, this is also a decidable problem. So now to wrap up, we have learned what a recursive language, what is recursively enumerable language, what is decidability, and we try to understand decidability more further by solving a couple of questions and truly understand what are decidable languages. Hope you have learned some things from this video, and that's it from me. My name is Siddhant. Thank you so much.